If you're preparing for a Snowflake interview, you'll want to brush up on your knowledge with the most common questions and their answers. This video will provide you with the top 25 questions that are often asked during such interviews. The aim is to equip you with an understanding of the kind of questions you may encounter and how best to respond to them. By familiarizing yourself with these questions and their answers, you can approach your Snowflake interview with confidence and assurance. 1. What is Snowflake, and how does it differ from traditional data warehouses? Snowflake is a cloud-based data warehousing platform that separates compute and storage resources, enabling scalable and efficient data storage and analytics. Unlike traditional data warehouses, Snowflake's architecture allows for instant elasticity, computing power adjustment without disrupting running jobs, and it supports diverse data, including structured and semi-structured data. It operates on a pay-as-you-go model, which can lead to cost efficiency as you only pay for the storage and compute resources you use. Snowflake also simplifies data sharing and provides robust security features, which sets it apart from traditional data warehouses. 2. Can you explain the architecture of Snowflake? Snowflake's architecture is a unique multi-cluster, shared data architecture designed for the cloud. It is divided into 3 key layers: storage, compute, and services. The storage layer is responsible for storing all structured and semi-structured data. It manages all aspects of data storage including organization, file size, structure, compression, metadata, statistics, and other aspects. The compute layer, also known as the processing layer, is where the virtual warehouses lie. It is responsible for executing all SQL operations sent from users and applications. Each virtual warehouse can access all the data in the storage layer and operates independently, enabling concurrent and high-speed data processing. The services layer coordinates the entire system, managing security, metadata, query optimization, and functionality like data sharing and data cloning. Each layer is isolated, scales independently, and works together to prevent any bottleneck in performance. 3. What are virtual warehouses in Snowflake? Virtual warehouses in Snowflake are computing clusters that allow you to execute queries. They are an integral part of Snowflake's architecture, providing the compute resources necessary for data processing. Unlike traditional data warehouses, virtual warehouses in Snowflake can be turned on or off, scaled up or down, and are independent of storage, providing flexibility and efficiency in managing your data workloads. The billing in Snowflake is also based on these virtual warehouses. You're only charged for the time that the warehouses are running, providing cost efficiency. Now, let's delve into the concept of virtual warehouses. In Snowflake, a virtual warehouse is essentially a set of compute resources. These are used to perform operations like loading data, running queries, and performing other SQL operations. The beauty of virtual warehouses is their scalability and independence. You can scale them up or down depending on your workload, and they operate independently of each other and the storage layer. This means you can have multiple virtual warehouses running in parallel, each performing different tasks. This not only boosts efficiency but also makes it easier to manage and optimize your data workloads. 4. How does Snowflake store data? Snowflake employs a unique method to store data by using cloud-based storage. This data is stored in a structured format, which simplifies the data retrieval process. As it operates in the cloud, it enables unlimited and elastic storage capacity. This significantly reduces the need for data storage management tasks such as capacity planning and storage optimization. Snowflake uses a columnar storage technique for storing data, which increases the speed and efficiency of specific queries. The use of micro-partitions improves performance by storing and retrieving data in small, manageable chunks. Data stored in Snowflake is automatically compressed and optimized for performance without any need for manual intervention. Additionally, Snowflake's architecture separates storage and computing functions, thus allowing each to scale independently. This separation ensures that you pay only for the storage and computing resources you use, providing cost-efficient data management. 5. What are micro-partitions, and why are they important? Micro-partitions are a unique feature of Snowflake that helps in efficient data management and improved query performance. They are automatically created when data is loaded into Snowflake, and each micro-partition typically holds between 50 MB and 500 MB of uncompressed data. They are immutable and columnar stored, which means once data is loaded, the micro-partitions don't change. The importance of micro-partitions lies in their role in reducing the amount of data scanned during query execution, thus improving performance. Snowflake maintains metadata about these partitions such as range of values, number of nulls, etc., and uses this metadata to skip over micro-partitions that don't contain required data. This process, known as pruning, significantly speeds up data retrieval and reduces the computational resources required for querying. Micro-partitions also play a vital role in Snowflake's data protection features like time travel and fail-safe. As they are immutable, we can access previous versions of data within the time travel period and during fail-safe period after time travel expires. 6. What is the purpose of the copy into command in Snowflake? The copy into command in Snowflake is used for data ingestion, enabling users to load data into tables from various sources. It accepts a file format specification, which can be CSV, JSON, AVRO, PARQUET, or ORC. This command can load data from either a named stage that has been previously created and includes a URL pointing to the data file or directly from a cloud storage location. The command is highly efficient, as it can split large data files into smaller parts and load them in parallel. This significantly reduces the time required for large-scale data ingestion. It also provides various options to handle errors during the data load process. 7. Can you explain the difference between a temporary table and a transient table in Snowflake? The primary difference between a temporary table and a transient table in Snowflake lies in their lifespan and persistency. A temporary table is a session-specific table that is automatically deleted at the end of the session. It is beneficial for operations that require a temporary workspace and its data is not shared among other sessions. On the other hand, a transient table is a non-session specific table that persists until explicitly dropped by the user. Although it retains data after a session ends, it does not maintain a history of changes, so you cannot use time travel to access or restore previous versions of data. This makes transient tables ideal for large datasets where maintaining historical changes is not necessary. Both types of tables are useful in different scenarios and can greatly enhance the efficiency of data operations in Snowflake. 8. What is a Snowflake stage, and how is it used? A Snowflake stage is essentially an area for storing data files that you want to load into Snowflake. It acts as a temporary storage location between the source system and your Snowflake database. Stages can be internal, owned and managed by Snowflake, or external, located on a cloud platform such as AWS S3, Google Cloud Storage, or Azure Blob Storage. The use statement is often used to select a stage for operations. For instance, you can copy data files from a stage into a Snowflake table using the copyinto command. Stages therefore play a crucial role in Snowflake's data loading operations, enabling efficient and organized transfer of data into the database. In the Snowflake environment, a stage is an area for storing data files that will be loaded into the system. This storage area can be internal, meaning it's managed by Snowflake, or external, residing on a cloud platform like AWS S3, Google Cloud Storage, or Azure Blob Storage. Stages can be temporary or permanent. Stages are utilized with the copyinto command, which copies data files from the stage into the Snowflake table. This command can be used for bulk data loading, making stages a critical component in efficient data transfer to Snowflake. Stages also allow for the management and organization of data files. 9. How do you create a simple table and insert data into it in Snowflake? Creating a simple table and inserting data into it in Snowflake is quite straightforward. First, you use the create table command to define the structure of your table. For example, create table my_table, ID number, name string, age number, closing parenthesis semicolon. This creates a new table named my_table with 3 columns, ID, name, and age. After creating the table, you can insert data into it using the insert into command. For example, insert into my_table values: 1. John Doe, 30, 2. Jane Doe, 25. This inserts 2 rows of data into the my_table. The first row contains the values 1, John Doe, and 30, and the second row contains the values 2, Jane Doe, and 25. 10. What is the significance of the flatten function in Snowflake? The flatten function in Snowflake is used to transform semi-structured data types into a tabular format. It is particularly helpful when dealing with JSON, ARRAY, or VARIANT data types. This function turns nested or repeated values into individual rows, making the data easier to work with. For instance, if you have a JSON object with multiple nested arrays, the flatten function can break it down into separate rows for each array element. This ability to handle semi-structured data is one of the unique features of Snowflake that differentiates it from traditional SQL-based systems, which often struggle with such data formats. By leveraging the flatten function, users can efficiently query and analyze semi-structured data alongside their structured data in Snowflake. 11. How do you handle sensitive data in Snowflake? Sensitive data in Snowflake can be handled through various methods to ensure security and compliance. One of the primary methods is using data masking. This involves disguising data so that sensitive information cannot be accessed by unauthorized users. Another method is to use role-based access control, RBAC, which allows specific roles to access sensitive data, ensuring only authorized personnel can view it. Additionally, Snowflake also supports encryption for data at rest and in transit, providing an extra layer of security. In terms of compliance, Snowflake adheres to various regulations such as GDPR, HIPAA, and SOC 2 Type 2, providing assurance that your sensitive data is managed in a compliant manner. Regular audits are also beneficial in ensuring data is handled correctly. 12. Explain what time travel is and provide a use case for it. Time travel in Snowflake is a unique feature that allows you to access historical data for a specific period. It's like having a time machine for your data, where you can go back and see what the data looked like at a certain point in time. This feature can be very useful in cases of accidental deletion or modification of data. One use case for time travel could be in a data recovery scenario. Suppose a user mistakenly deletes important data from a table. With the time travel feature, you can retrieve the deleted data by going back to a point in time before the deletion occurred. Another use case could be for auditing purposes. If there is a need to investigate data changes, time travel can provide a detailed history of the data modifications. 13. What are materialized views in Snowflake, and how do they differ from standard views? Materialized views in Snowflake are a form of precomputed result set that is based on a specified query. They are physically materialized and stored within Snowflake, which enables faster query performance as the data does not need to be computed each time the view is accessed. On the other hand, standard views are not physically materialized. Instead, they are virtual and the query that defines the view is run every time the view is accessed. This can potentially lead to slower query performance, particularly if the underlying dataset is large or the query is complex. One key difference between materialized views and standard views is how they handle data changes. With standard views, changes in the underlying data are immediately reflected in the view upon access. For materialized views, the changes in the underlying data are not immediately reflected. Instead, the materialized view needs to be refreshed to capture the changes. Materialized views in Snowflake offer significant benefits, particularly when dealing with large datasets or complex queries. They can greatly enhance query performance by precomputing and storing the result set, reducing the computational load each time the view is accessed. However, it's important to consider the trade-off between performance and data freshness, as changes in the underlying data are not immediately reflected in the materialized view. Regular refreshes may be required to ensure the view remains up to date. While standard views may not offer the same performance advantage, they do ensure that the most current data is always presented. 14. How do you implement role-based access control, RBAC, Snowflake? Implementing role-based access control, RBAC, Snowflake entails the creation of roles and granting them to users. This is done by using the create role command and then assigning access privileges to the role. For instance, roles can be granted select, insert, update, delete, and other privileges on specific objects. These roles can be hierarchical, where higher-level roles inherit the privileges of the lower-level roles. For instance, if there are 3 roles, Role 1, ROLE2, and Role 3 and Role 1 is granted to ROLE2, Role 2 can use all the privileges of Role 1. Similarly, if Role 2 is granted ROLE3, Role 3 can exercise the privileges of both Role 1 and ROLE2. The power of RBAC lies in its flexibility and granularity. It allows the administrators to control who can access what data, when, and how. This facilitates the implementation of the principle of least privilege, POLP, which is a computer security concept in which a user is given the minimum levels of access necessary to complete his/her job functions. Remember, managing roles and privileges is a continuous process and should be reviewed regularly for any necessary adjustments. 15. What strategies would you use to optimize SQL queries for performance in Snowflake? In order to optimize SQL queries for performance in Snowflake, there are several strategies that can be utilized. One of these is to make use of Snowflake's ability to automatically optimize data storage and computation. By setting the right configuration and using the right data types, you can ensure that your queries run more efficiently. Another strategy is to use Snowflake's built-in tools for performance optimization. These include the query profile, which allows you overall insights into how your queries are performing, and the query history, which provides detailed information about past queries. You should also consider using Snowflake's caching capabilities to improve query performance. When a query is executed, Snowflake stores the result in a cache, which can then be reused for subsequent queries that are identical to the original. Finally, it's important to write efficient SQL code. This could involve using joins where appropriate, avoiding sub-queries, and making use of indexes. Remember, optimizing SQL queries is not a one-time task, but a continuous process that requires regular monitoring and adjustments as necessary. 16. Describe how you would manage compute costs in Snowflake. Managing compute costs in Snowflake requires strategic use of Snowflake's unique features. Firstly, I would leverage the fact that Snowflake separates storage and compute resources. This means you only pay for the compute power you use. Therefore, optimizing query performance can significantly reduce costs. Secondly, Snowflake's auto-suspend and auto-resume features can be utilized to ensure that you are not charged for compute resources when they're not in use. Thirdly, I would make use of Snowflake's multi-cluster warehouses for larger tasks to ensure that individual queries do not slow down the entire system, thereby maximizing efficiency and minimizing cost. Lastly, using the right size of the warehouse for each task can also cut down costs, smaller warehouses for less intensive tasks and larger ones for more intensive tasks. Managing compute costs also involves regular monitoring and adjusting of your resource usage based on your needs and budget. Regular audits can help identify inefficiencies in areas where resources can be scaled down. In addition, using Snowflake's Resource Monitor can provide alerts about usage and limit consumption if necessary. 17. Can you explain the concept of zero-copy cloning in Snowflake? Zero-copy cloning in Snowflake is a unique feature that allows users to clone databases, schemas, tables, or other objects without duplicating any data. The process is nearly instantaneous, regardless of the size of the data object. This is possible because Snowflake uses metadata to manage data, not actual data duplication. When a clone is created, Snowflake simply creates a new reference to the existing data. This results in significant time and storage savings. Zero-copy clones can be used for various purposes such as testing, development, data recovery, and more. 18. How does Snowpipe facilitate continuous data loading? Snowpipe is a feature in Snowflake that allows for efficient and continuous data loading. It's particularly useful for near real-time data ingestion, as it can load data as soon as it's available. Snowpipe operates by listening for notifications from an external stage whenever new data is available. When it receives a notification, it automatically loads the new data into a specified table. This automatic and continuous loading of data, without any manual intervention, is what sets Snowpipe apart from other data loading methods in Snowflake. Snowpipe allows for the seamless ingestion of data by employing a listen and load approach. It monitors an external stage, like an S3 bucket, for new data and instantly loads it into the specified Snowflake table when it arrives. This functionality is especially beneficial when dealing with real-time data analysis or streaming data. This automated data loading process eliminates the need for manual intervention, making it highly efficient. So, by using Snowpipe, you can ensure that your Snowflake data warehouse always has the most recent data available for your queries and data analysis needs. 19. What challenges have you faced when scaling data operations in Snowflake, and how did you overcome them? Scaling data operations in Snowflake can present several challenges. One issue I encountered involved the management of compute resources. During peak usage times, it was difficult to maintain optimal performance without incurring high costs. I addressed this by implementing a multi-clustered virtual warehouse, which allowed for automatic scaling based on demand and helped manage costs. Another challenge was handling large volumes of data. Traditional ETL processes proved inefficient, so I utilized Snowflake's Snowpipe feature to streamline continuous, near real-time data ingestion. Finally, ensuring data security and privacy was a constant concern. To tackle this, I leveraged Snowflake's robust security features, like end-to-end encryption and role-based access control. 20. How do you monitor and manage virtual warehouse performance in Snowflake? In Snowflake, monitoring and managing virtual warehouse performance involves several steps. Firstly, you can use the Snowflake web interface to check the real-time status of your virtual warehouse. It provides information about the number of running, queued, and blocked queries. Additionally, you can see the active and suspended warehouses, which can help identify any performance issues. Secondly, you can use the Snowflake's account_usage views to track historical usage data. It helps to understand the warehouse's performance over time. Next, it's crucial to manage the size of your virtual warehouse appropriately. If your queries are running slow, then you might need to increase the size of your warehouse. However, if you have a small number of queries and your warehouse is large, you might be wasting resources. Finally, using the resource_monitor feature, you can set limits on the computing resources consumed by a virtual warehouse. This feature allows you to automatically suspend or resize your warehouse if it exceeds the defined limits, ensuring optimal performance and cost control. Remember, the key to managing virtual warehouse performance in Snowflake effectively lies in regular monitoring, understanding usage patterns, and adjusting resources accordingly. It's a dynamic process that requires continuous attention and adjustments. 21. Describe your experience with integrating external data sources into Snowflake. In my experience, integrating external data sources into Snowflake was a multi-step process, but Snowflake's powerful functionality made it relatively straightforward. First, I would identify and prepare the external data source for integration. This could involve a wide range of actions, from cleaning the data to ensuring it's in a format Snowflake can process. Once the external data source was prepared, I would use Snowflake's create external table command to create a new table that references the external data. This command required me to specify the data source, the file format, and the structure of the data, among other things. After creating the external table, I could then use Snowflake's copy into command to load the data into a Snowflake table. This command allowed me to specify various options to control how the data was loaded, such as whether to perform error checking or validation. Throughout this process, I found Snowflake's support for a wide range of data formats and its powerful query capabilities to be particularly useful. These features enabled me to integrate a wide variety of external data sources into Snowflake with relative ease. 22. What methods do you use for error handling and debugging in your Snowflake workflows? Error handling and debugging in Snowflake workflows can include various methods. One common practice is using the try-catch blocks to handle errors during code execution. This allows the program to continue running even if an error occurs. Additionally, Snowflake provides system functions like error_message and error_stack that can be used to retrieve error details. Another method involves the use of Snowflake's query history. This feature allows users to review and monitor all SQL queries made in their account. Any errors that occurred during these queries are displayed here, which can be handy for debugging. For more sophisticated error tracing, it's recommended to use the system$pipe_status function. It provides detailed information about the execution status and errors of a specific pipe. In terms of debugging, regular code reviews and using debuggers in the Integrated Development Environment (IDE) can be helpful. The use of extensive logging can also aid in identifying and resolving issues quickly. When encountering errors, I typically begin by investigating the error message returned by Snowflake. This message usually provides substantial insight into the issue. I also leverage Snowflake's robust logging capabilities, which can reveal patterns or anomalies that might be contributing to the problem. In some cases, I might utilize the validate function to check the data loaded into a table against the original source data, ensuring consistency. If I'm dealing with a more complex issue, I might use the explain command to understand the execution plan of a query, which can help identify inefficiencies or errors. My debugging process is iterative, and I continually retest my code after making adjustments to ensure the issue is fully resolved. This iterative approach, combined with careful attention to error messages and logs, allows me to effectively handle errors and debug my Snowflake workflows. 23. Can you explain how to set up failover and disaster recovery in a Snowflake environment? In Snowflake, setting up failover and disaster recovery is a straightforward process due to its built-in features. Snowflake's architecture automatically replicates data across multiple availability zones within a region for high availability and failover. If there's an issue with a zone, Snowflake automatically fails over to a functioning zone without any intervention. For disaster recovery across regions, Snowflake uses features like cross-region replication and failover. Cross-region replication allows for the creation of secondary copies of your databases in other regions. If the primary region is unavailable, you can fail over to your secondary region. Once the primary region is back, you can fail back from the secondary to the primary region. Remember, these operations are not automatic and require manual initiation. Regular testing of your disaster recovery strategy is also crucial to ensure you can recover your data when needed. 24. Discuss your approach to implementing data governance within a Snowflake architecture. My approach to data governance within Snowflake architecture involves multiple layers. I start by defining clear policies and rules for data usage. This includes determining who can access what data, how data can be used, and what security measures need to be in place. Then, I ensure that these policies are enforced using Snowflake's robust access control features. This might involve setting up roles and permissions, implementing data masking, and so on. Next, I focus on data quality and integrity. I might use Snowflake's built-in data validation capabilities, or implement custom checks as needed. Lastly, I ensure transparency and traceability of data. This might involve setting up a data catalog, implementing data lineage tracking, and so on. Through all these measures, I aim to ensure that data in the Snowflake architecture is secure, trustworthy, and can be used effectively for business purposes. This approach also helps to comply with various regulatory requirements. 25. Share an experience where you optimized a Snowflake environment for better performance or cost efficiency. In my previous role, we were dealing with large amounts of data stored in Snowflake. The cost was escalating due to the increase in storage and compute resources. I analyzed the usage patterns and identified a few areas where we could optimize. First, I adjusted the virtual warehouse sizes based on the workload, which reduced the compute costs significantly. Second, I implemented automatic suspension and resumption of unused warehouses, saving on idle time costs. Third, I moved some of the historical data to less expensive storage. This combination of strategies reduced our Snowflake expenses by nearly 20%. I hope this information about the top 25 Snowflake interview questions and answers has been beneficial. It's crucial to understand the structure and usage of Snowflake to excel in your job interview. Remember, thorough preparation is a key factor to success. If you found this video helpful, please hit the like button. If you want to stay updated with more such content, don't forget to subscribe to our channel. Best of luck in your preparation and in your upcoming interviews.